Good morning, everyone. I trust you all are doing well. So, today in this video, we will discuss a very important topic of class 12th physics from the chapter Dual Nature of Matter and Radiation. And the topic is de Broglie dualistic hypothesis. So, firstly, we will see the dual nature of radiation, and after, we will see the hypothesis given by the de Broglie for the dualistic nature of matter and radiation. So, dual nature of radiation. Dual nature of radiation means somewhere times the radiation belongs like an particle, sometimes it behave like a consist of a wave. So in physics, some phenomena like interference, diffraction, polarization can be explained only on wave nature of light, but some other phenomena like photoelectric effect, Compton effect are explained when radiation is to be considered as particle nature. It means radiation sometimes behaves as a wave and sometimes as a particle. This is the dual nature of radiation. De Broglie dualistic hypothesis. According to De Broglie, every moving particle is associated with a wave which controls the particle in every respect. The wave associated with the particle is called de Broglie wave or matter wave, whose wavelength is given by the relation lambda will equal to h by mp, where h represents the Planck's constant, m represents the mass of the particle, and v represents the velocity of the particle. Basically, the de Broglie combine the both equation given by first equation given by Planck's quantum theory and another given by the Einstein mass energy relation. So Planck's quantum theory is energy will equal to h mu and Einstein mass energy relation is energy will equal to mc square. These two equations give the value of energy and we are equating these two values. We have mc square will equal to h mu. From here we will get m will equal to h mu by c square. As we all know that frequency is equal to speed of light divided by the wavelength. So here you can replace mu by c by lambda. Mu will equal to c divided by lambda. From where you have the relation lambda will equal to h divided by mc. Hanji. The product of m into c will equal to the momentum and represented by p. So lambda will equal to h divided by p. De Broglie assumed that this equation lambda will equal to h by p is equally applicable to both photons of radiation and material particle. Here m represent the mass of the material particle, v represent the velocity of the particle. So momentum of the particle will be represented by the symbol p, which will equal to m into v. Wavelength associated with moving material particle lambda will equal to h by p, which will equal to h by mv. So this is all about the de Broglie dualistic hypothesis and the derivation of de Broglie wavelength. Now we will see the conclusions obtained from this equation. The dualistic equation is represented by the symbol lambda will equal to h upon p, where p represents the momentum that will equal to m into v, the product of mass into velocity. If velocity you take equal to 0, if velocity is going to 0, then you have the relation lambda will equal to h upon 0. That means lambda is nearly equal to or equal to infinity. अगर आप यहाँ पे velocity की value को 0 रख देते हैं, so you will have that wavelength will equal to infinity. It means waves are associated the material particle only if they are in motion. आपको क्या चाहिए? अगर आप चाहते हैं कि वेव एसोसिएटेड रहे मटेरियल पार्टिकल के साथ, तो ऑलवेज आपकी जो वेव्स होनी चाहिए वो किस में होनी चाहिए? मोशन में होनी चाहिए. आप यहाँ पे स्टेबल कंडीशन को कंसिडर नहीं करेंगे. एवरी टाइम पार्टिकल इज इन motion. Now next, as we see that wavelength is inversely proportional to momentum, that means greater the momentum of the particle, the shorter is the wavelength, and also the vice versa of the case is also possible. Now the third next conclusion is de Broglie wavelength of a particle is independent of the charge of the particle. You see here is no relationship of the charge with the wavelength. That means wavelength is independent of the charge. Hence these waves cannot be electromagnetic in nature. Next, the fourth conclusion here we have, if the velocity of particle is comparable to the velocity of light, that means if v is comparable to c, then you have the mass of the particle is given by the relation m will equal to m naught under root 1 minus v square by c square, and the relationship of de Broglie wavelength is lambda will equal to h upon P. So this P will equal to m naught, we are taking here mv, m की जगह पे replace कर दीजिए m naught under root 1 minus v square divided by c square. The last point, since the position of the wave is not exact, hence there is some uncertainty about the exact location of the particle. क्योंकि हमें यहाँ पे वेव की जो पोजीशन है वो एग्जैक्टली नहीं पता, तो हम उसकी एग्जैक्ट लोकेशन भी पार्टिकल्स की नहीं बता सकते. देर इज अ रीजन इन विच इंफॉर्मेशन अबाउट द पार्टिकल इज नॉट एग्जैक्टली नोन. Now we will discuss the relation for de Broglie wavelength and the temperature. As we all know, according to kinetic theory of matter, kinetic energy of particle at temperature T is given by the relation K will equal to 3 by 2 kT, and we all are familiar to the concept of kinetic energy. The kinetic energy of particle is given by the relation half mv square. So from here we will have K will equal to half mv square. So 2 km will equal to m square v square. Multiply this equation by m and divide this equation by m. You have m यहाँ से यहाँ multiplication में चला जाएगा and m into m square you have. So from here you will have the value of mv, which will equal to under root 2 mk. Use this value to calculate the momentum. As you all know that momentum will equal to mass into velocity. So mv will equal to under root 2 mk. So you have the value of p, which will equal to under root 2m. Put this value of kinetic energy according to kinetic theory of matter. Kinetic energy of a particle at temperature T is given by 3 by 2 kT. So put this value here. We have 3 by 2 kT. So finally we have the value of momentum that comes out to be under root 3 mkt. Lambda will equal to h upon p by Planck's quantum theory or de Broglie wavelength. It is according to the concept of de Broglie. So lambda is equal to h by p is the relation given by the de Broglie. So here we have h divided by under root 3 mkt. This is the relationship for de Broglie wavelength and the temperature. Now we will see the another equation which involves de Broglie wavelength of an electron moving through a potential difference V. Means अब हम de Broglie wavelength की वो equation calculate करने वाले हैं, drive करने वाले हैं जिसमें एक electron move करता है through a potential difference V. Whenever a electron of mass m and charge E is accelerated through a potential difference V, the kinetic energy acquired by the electron is given by this kinetic energy will equal to EV. Kinetic energy formulation is half mv square. This will equal to EV. From here you have m square v square will equal to 2 mev, and the value of mv will equal to 2 mev under root 2 mev. If lambda is a de Broglie wavelength associated with the electron, then lambda will equal to h upon mv. So put this value of mv in this equation. Mv will equal to under root 2 mev. This small v represents the velocity, where this capital V represents the potential difference. So lambda will equal to h upon under root 2 mev. Put the value of h, put the value of mass, put the value of electron charge, put the value of that potential difference. We don't know about the potential, so just keep it like capital V. After solving this equation, you have the value that lambda will equal to 12 upon 12.27 divided by under root V, and that value of lambda is comes out in the term of angstrom. This is all about de Broglie relationship and their formulations.